Okay, so let's talk a bit about stem cells. Let's back up the bus a little bit because people hear stem cells and they think different things. Definitely, there's been a lot of noise about stem cell clinics in the US, like some clinics in the US who were using stem cells who got shut down. There's stem cells that you get from another source, like from cord blood. And of course, the stem cells that got this whole area into hot water, embryonic stem cells. And then there's the stem cells that we can take out of our own fat or our own body. So maybe if you wouldn't mind giving us a little bit of an orientation in this stem cell universe, and then really hone in on the ones that you're really talking about in your book.
Okay. So stem cells, just to begin with, what are they? Probably the best way to understand what stem cells are is to first talk about what is not a stem cell. Every cell of your body are known as somatic cells, like a cell of your muscle, a cell of your lung, of your pancreas. They do one specific thing. Like a cell of your pancreas will do insulin. Yeah. A cell of your retina will be excited by light, will send a signal to your brain. That's it. That's the only thing that cell is going to do. A cell will never transform into another type of cell. And so they're fixed. And to a large extent, they do not multiply. So at the end of that spectrum, you have stem cells. Stem cells are nothing in the fact that a stem cell doesn't do anything in your body. Its existence or its role is to transform into something else that will be a somatic cell. So they have the ability to transform into virtually anything in the body. They can multiply during the entire life of an individual, at least in the bone marrow, and they live in your bone marrow. They are immortal. So that's what stem cells are. They are, generally speaking, based of everything that people may have heard in the media since the early 2000s, embryonic stem cells and adult stem cells. There was a big push to make everybody understand that embryonic stem cells was really the future. If we have time, we can go into the politics of that. It was highly political because everybody knows in the field of stem cell research that embryonic stem cells are powerful, but they're actually too powerful, meaning that an embryonic stem cell is a stem cell, let's say a one cell that can then become a full organism. Yeah. So you take one cell, you develop it, and you get the fully formed body, if you want. So that stem cell can become everything in the body. So if you take an embryonic stem cells and you put it in the skin, for example, you just wait a few weeks, and you're very likely to get what is called a teratoma, which is a lump of tissue where you will have heart cells, beating heart cells, a few pieces of teeth, some hair, some liver, some muscles. It's a lump of everything. It shows you the power of embryonic stem cells. As the embryo develops, becomes the fetus, when you're just about to be born, that the stem cells are now called adult stem cells. So the stem cells that you find in an umbilical cord or a placenta, they are, for all intent and purposes, adult stem cells. So it does not really refer to an adult. It refers to an organism after birth. So these are adult stem cells. These adult stem cells have been known for ages, let's say for a number of decades, let's say half a century, a little more, to be precursors to blood cells. Let's say the 1950s. The precursors to blood cells, they're responsible to make your blood. And that understanding was how could I say, the knowledge about stem cells until discoveries were made early 2000 that adult stem cells were also able to become cells of virtually any tissue in the body. But the difference compared to embryonic stem cells is that if you take an adult stem cells and you put it in the skin, it will only become skin cells. You put it in the heart, it only becomes heart cells. So it is true that they're more limited, but that limitation is actually not from a therapeutic standpoint. It's limited, it's that it's not too wild. It will not lead to cancer, teratomas. So from a purely therapeutic standpoint, the future is with adult stem cells. It's only with adult stem cells. They still use embryonic stem cells. I won't go into all the details, but it's mostly for drug discovery. If you can take an embryonic stem cells and make it become a heart in a test tube, then a human heart in a test tube, then you can test drugs on these human heart cells. So it's for drug discovery, essentially. For treatment, therapeutics, the future is with adult stem cells. In the whole world of adult stem cells, therefore, you have umbilical cord, placenta stem cells that you can collect from placenta, from the umbilical cord. You have stem cells from fat tissue. Your fat tissue contains a lot of stem cells. It's easy to extract some fat tissue and spin it in a centrifuge, extract stem cells, and then I can re-inject these stem cells. It's autologous, meaning that they are your own. So it's your own stem cells that you use. You can have stem cells everywhere in every tissue. The main question is, how do you get them? So you can have stem cells, for example, from a tooth. So a child that loses a tooth, you have dental pulp stem cells that you can extract. So there's a whole market in Thailand, for example, when your kid loses a tooth. Well, you put that into a little test tube, you send that to the facility that will culture these stem cells, propagate them, and then you go there and pay them a fee to get an injection of dental pulp stem cells. So there are different hair follicle stem cells. There are different types of stem cells. Today, the most commonly used is adipose stem cells, meaning your fat stem cells.
Yeah.
But the base of all these stem cells is the bone marrow. This is where they come. This is where they are immortal. When you find them in a tissue, it came from the bone marrow, migrated in that tissue to become a tissue-specific stem cell. So the work that I have done mostly started from when all of this was observed. The thing that, aside from the discoveries that we did with the plant, and I'm sure we will have a chance to talk about this,
for sure.
But for me, the great question is, or was, if adult stem cells have such amazing potential and they are isolating them from your body, from your fat tissue, for example, and then re-injecting them in your body, you didn't do anything to these stem cells. They're not better because you took them out and you put them back in. So if they're there to begin with, what is their natural role? And is there a way to tap into these stem cells? So the work that I have done focused on how can we support or stimulate the release of our own stem cells in our own bone marrow so that we can put more in circulation, which is exactly what you achieve by an injection. You have more in circulation through an injection. What about having more through releasing your own?